Hi, I'm Riccardo Maderna from Politecnico di Milano, and today I present you our work Flexible Scheduling and Wearable Haptics for Human-Robot Collaborative Assembly that we perform with our friends from the University of Siena. This work presents a human-robot collaboration paradigm to fully exploit human and robot capabilities for product assembly operations. The system goes beyond the pure human-robot coexistence and achieves a flexible and human-aware integration of different operators in a work cell. To do so, we developed a dynamic scheduler that can plan the operation of multiple agents, and also a new tactile communication paradigm is proposed to communicate instructions to the human through visual and haptic cues. The scheduler exploits a digital twin of the work cell to plan the optimal instruction for all the agents, and it solves online both task allocation and sequencing so to dynamically adapt the plan to the process variability. In particular, the scheduling algorithms support multiple agents working together on multiple products at the same time. It also accounts for the variability in the duration of the human tasks and the occurrence of robot faults. So overall, these features allow to increase the productivity of the assembly process. Communication with the scheduler is bidirectional. On the one hand, the scheduling algorithm communicates the optimal instructions to the humans and the robots in the work cell. On the other hand, the agents inform the scheduler about operation completion and, in case of the robots, about faults that have occurred. The communication interface with the human is composed of a screen for visual instruction and two types of wearable devices. In particular, human operators press a button on a ring to signal the completion of the operation. The operator wears also two bracelets that are used to communicate instruction from the scheduler through vibration patterns. The operator is guided toward the portion of the workspace where the next operation starts, depending on which bracelet is activated and how many vibration bursts compose the message. The operator we tested our approach by involving 16 participants in a realistic scenario shown in the video, and the experiments shown that both the dynamic scheduler and the combination of visual and haptics instructions help to increase the system performance. This concludes the brief overview of our work. Thank you for the attention.